Hi everyone, this is Mr. H again, and welcome back to Math Hub by Mr. H. In this video, you will learn about implicit differentiation. So first of all, what is implicit differentiation? Well, implicit differentiation is one of the techniques in calculus which is used to find the derivative of a function when the equation is not explicitly solved for one variable in terms of another. Alright, say for example you are given an equation which is x cubed minus x squared y squared plus x equals 1, and you're asked to find the derivative of this. So definitely you will be applying the technique which is implicit differentiation, because the y and x variables are mixed together. And with that, we use implicit differentiation. Alright, so let's proceed with the examples. Example 1. Find the derivative or dy over dx of 3 squared root of x minus 2 squared root of y equals 25. So like what I mentioned earlier, finding the derivative of a function using implicit differentiation is the same process on how you find the derivative of the other functions. So you will be applying the same rules. However, here, the x and y variables are mixed together. Alright, so what you can do first is to rewrite this term and this term first into exponential form. So this will be 3 times x to the power of 1/2 minus 2 times y to the power of 1/2 equals 25. Alright, so we get the derivative of each term first. So we begin with this one. So we're going to be applying the power rule. So we'll have 3 times 1/2, then copy the base x, and for the exponent it will be 1/2 minus 1. Alright, so next is the second term. Alright, so we'll have -2 power rule, so we bring down the exponent, so times 1/2, then we copy y, then the exponent will be 1/2 minus 1. We need to get the derivative of y, which is y prime, or dy over dx. So this is where the dy dx starts to appear. Equals derivative of 25 is 0. And then we simplify. So 3 times 1/2 is 3 over 2. Then we copy the base x. And we'll have 1/2 minus 1, which is -1/2. And for the next term, so we simplify. This is gonna cancel out. We're gonna be 1 times 1 is 1. So it's gonna be -1. Then you copy y. So 1/2 minus 1 is -1/2. So you have dy over dx equals 0. Alright, so let's clear each term from a negative exponent. So let's rewrite this first term. It's going to be 3 divided by 2 times x to the power of 1/2. So same goes for this one as well. So it will be 1 divided by y to the power of 1/2. Then you'll have dy over dx equals 0. And so we can still rewrite this. We'll have 3 divided by 2 square root of x minus 1 divided by square root of y dy over dx equals 0. So let's continue the working here. Next, we'll separate this term. On the left hand side, we'll have -1 over square root of y dy over dx equals, so we move this term over to the right hand side, which will make it -3 over 2 square root of x And what we need to do here is we need to divide both sides by -1 over square root of y. So this one will be canceled out, or it's going to become 1. And we'll have dy over dx on the left-hand side. And so we divide this. So negative divided by negative is positive. And so I'll just copy the numerator first. And then for this one, divisor, I'll get the reciprocal of that and change to multiplication. So that will be square root of y. So dy over dx equals 3 square root of y divided by 2 square root of x, which is the answer. Alright, do you find this example interesting? If you do, hit the like button. If you haven't subscribed yet to my channel, so please hit the subscribe button as well. And let's proceed with the second example. Find the derivative of 15x plus x squared y squared equals x to the power of 6 over 3 plus 18x. So we're going to be starting with the first term, which is 15x. So the derivative of 15x is 15 plus, so for the second term, we need to apply product rule here. We take the first factor, which is x squared, and then we get the derivative of this y squared. So derivative of y squared is 2y y prime, plus we take the second factor, which is y squared, times the derivative of the first factor, which is 2x. Next, equal to this term. So we separate 1 over 3, and then we take the derivative of this, applying the power rule. So it's going to be times 6 x to the power of 6 minus 1 plus derivative of the last term, which is 18. And then we simplify. So we have here 15 plus 2 x squared y prime plus 2xy squared will be equal to 6 divided by 3 is 2. X to the power of 6 minus 1 is 5 plus 18. The next thing we need to do here is we need to separate the term with y prime. 2x squared y prime will be equal to, so we copy everything from the right hand side, so 2x to the power of 5 plus 18, so will be minus 2xy squared minus 15. And then we simplify, so 2x squared y prime will be equal to 2x to the 5th, so minus 2xy squared. 18 minus 15 is positive 3. And the last step will be dividing both sides by 2x squared y. So this will be 1. We cancel that out, or 1. And we'll have y prime equals all of this. Alright, but then we can simplify the final answer. You can actually write it separately per term. So you'll have 2x to the power of 5 divided by 2x squared y minus 2xy squared divided by 2x squared y plus 3 divided by 2x squared y. And then we can simplify each term. So we'll have y prime equals, so 2 gets cancelled out, or will be equal to 1. And for the variable x will be x cubed and y variable is left in the denominator, minus, so 2 divided by 2 is 1, and for the variable x, it will be x in the denominator, there will be y in the numerator, and for the last term, we copy everything, and that is our final answer. Let's take a look at example number 3. Find dy over dx of quantity 11y minus 2x to the power of 3 minus y equals 1 plus 50x. Alright, so we find the derivative of the first term first. So we're going to be applying here the chain rule. So the derivative of that will be 3 times 11y minus 2x to the power of 3 minus 1 times the derivative of the base. So 11y will be 11 dy over dx. Derivative of negative 2x is negative 2. Next is the derivative of negative y, which is negative dy over dx, equals derivative of 1, and a constant is 0, and derivative of 50x is 50. And then we simplify, so will be 3 times 11y minus 2x to the power of 2. And actually we can expand this, so it's gonna be square of 11y will be 121y squared, minus, we take this times this one, then times 2. So 2 times 11 is 22, times 2 is 44. Then we multiply x and y, plus we take the last term and square it. So 2 times 2 is 4, and then x times x is x squared. So that is the expanded form of this one. Alright, next we copy 11 dy over dx minus 2 minus dy over dx equals 50. Alright, so the next thing we need to do is apply the distributive property here. So 3 times 121 y squared is 363 y squared, minus 44 times 3 is 132 xy, plus 4 times 3 is 12 x squared, and then we copy 11 dy over dx minus 2 minus dy over dx equals 50. So this is actually one factor. And so what we need to do next is we need to apply the distributive property here. Alright, so we'll have 11 dy over dx times this whole thing. So we just copy. Minus 2 times the whole thing. And then we copy minus dy over dx equals 50. So the next step we need to do is we need to put together the terms that have dy over dx, which are this term and this term. So we can keep them on the left hand side, and the rest of the terms that do not have dy over dx will be on the other side of the equation. So we just simply copy this and this one. So it's going to be 50 plus this whole thing. Next is we need to factor out dy over dx from the left hand side. So dy over dx times, if we take out dy over dx from this term, definitely we will be left with 11 times this whole thing. Minus 1. And for the right hand side, we just copy everything. Alright, next is we need to divide both sides of the equation by this whole thing, because we need dy over dx left on the left hand side of the equation since we're solving for that. Alright, and then we cancel this out. So this one divided by this one is equal to 1. Definitely the left hand side will only have dy over dx. And that's going to be equal to all of this here on the right hand side. So be careful. You cannot cancel this and this one. That will not be allowed. Alright, so we copy everything from the right hand side of the equation. Actually, this is already the final answer, but if you want it written in expanded form, then alright, for the numerator we just need to apply the distributive property here. So 2 times 363y squared is 726y squared. So 2 times negative 132 is negative 264 xy plus 24x squared. So you can also expand this part in the denominator. So we'll have 11 times 363. It's going to be 3,993 y squared. Then 11 times negative 132, it's negative 1,452 xy plus 11 times 12 is 132 x squared, and then we copy minus 1. You can write it as 24 x squared minus 264 xy plus 726 y squared plus 50 divided by 132 x squared minus 1452 xy plus 3,993 y squared minus 1. Any of these three will do, okay? But this one is the most organized answer. Alright, so that's example number 3, guys. If you think that this video is insightful, remember to hit the like button, or you can also drop a comment below. And if you haven't subscribed yet to my channel, please do so. Once again, this is Mr. H, and thank you very much for watching this video. I'll see you in the next one.